Hi, in this lesson, we're going to look at another approach of machine learning, unsupervised learning. Remember, supervised learning is trained by us using labeled data features. This model is very useful when we have a nicely labeled data set, but what if we don't have labeled data? Can we learn without that supervision? That's where unsupervised learning is a useful approach. We are very good at learning from our own observations of the world around us, without anyone providing us with answers. Imagine we are given a pile of leaves and are asked to make 3 groups based on their similar features. We may come up with something like this. Without being told exactly how to group them, or by what qualities, we were able to come up with 3 groups of leaves that more or less resemble one another. This is an example of what we call unsupervised learning, and it might help reveal something about a particular grouping of leaves that we might not have discovered on our own. With unsupervised learning, the teacher or supervisor is not present, which means that our training dataset will have features but no labels. Here we have a selection of leaf data. We are not specifically telling the model which group each leaf belongs to during the training process. The model does the exploring on its own, looking for patterns amongst the features. Turns out computers are pretty good at this, even better than humans when there are a lot of features or rows of data. Let's look at a simplified version of our leaf data. We are going to plot each leaf on our chart depending on its width and length. Then we'll use this data to train an unsupervised learning algorithm called a clustering algorithm. We'll tell it that we want 3 groups or clusters and let it loose to learn about the data on its own. When it's done, it has determined 3 clusters among the leaves that look something like this. Now, these clusters may seem obvious to us for this simple example, but imagine if you have 10 different features instead of 2 and thousands of different leaves. Of course, there is no one right way to cluster data either, and training the same model with slight adjustments may result in slightly different groupings. With our trained model in place, we can now use these groupings to learn more about the characteristics of each group and dig into some of the similarities and differences. Another example of clustering could be using different body measurements, like for the chest, arm, wrist, forearm, neck, etc., to create groupings for shirt sizes. This could allow us to effectively set what dimensions each small, medium, large, extra large size will be best to accommodate the variations in shapes and sizes of their customers. Like supervised learning, there are a lot of really interesting examples that use unsupervised learning algorithms. Customer segmentation is a popular use of unsupervised models. Imagine that you are a business with over 10,000 different customers. You want to send emails and marketing materials that are relevant to them. Being able to customize these communications for different groupings of customers will be much more effective than just sending out one general message. Unsupervised learning algorithms can help create the customer groups based on their similarities. Shopping cart association and similar applications can look at patterns of product purchases between customers. For example, let's say that after digging into a local grocery store's data, the algorithms reveal that customers who buy cereal also tend to buy a variety of fruit like bananas and berries. This information can be used by the store to think strategically about product placement in the store. Or, let's say an online retailer learns that customers who buy shag rugs are also interested in bohemian-style pillows. Now, when a customer places a shag rug in their shopping cart, the website could also recommend that they take a look at a few bohemian pillows too. If you've ever watched any videos on streaming platforms, social apps, or YouTube, or have listened to music on a service like Spotify, you have experienced the joy and the effectiveness of unsupervised recommendation systems. Similar to product associations and customer segmentations, these algorithms are learning a lot about the content each person consumes and is able to recommend the next video or song based on your patterns and those of other similar consumers. A final common application of these unsupervised algorithms is to use them to help flag anomalies in data. Anomalies are data points that stand out as significantly different from other nearby data points. For example, if you tend not to buy expensive products or shop at Walmart, a $2,000 TV purchase at Walmart will stand out as weird. A bank may use an unsupervised learning platform to detect these odd purchases among their customers and flag them to look into. There is one more learning model we'll look into next lesson. For now, it's your turn to explore more about unsupervised learning.